Hey guys, so welcome to Unit 5. Our lesson today is called Properties of Logarithms. So we have a few rules here before we start the examples. We have the product of property. So log base b of m plus log base b of n is the same exact thing as log base b of m times n. Then we have a subtraction problem. Log base b of m minus log base b of n is the same thing as log base b of m divided by n. Notice how the bases are exactly the same for each property. Then what if you have a quotient? Okay, so not a quotient, I'm sorry, a power. So p times log base b of m is exactly the same thing as log base b of m to the p power. And again, you may not distribute logs, okay? The reason for all of these properties of log is because if you remember, if you had an exponential, let's say you got b to the m, right? Times b to the n. In exponential, that becomes b to the m plus n. So log is the inverse of exponential. So that's why in log, if it's addition, it becomes multiplication. Similarly to quotient property of log. Back in the days, if you had b to the m divided by b to the n, then this is when we subtracted our exponents. So we do, okay, m minus n if the bases are identical. In logs, the bases are still must be identical. Then in exponential, back in the days when we had power to the power, so b to the m raised to the n, then we multiply those exponents. Okay, so it becomes b to the n times n. Well, in log, we go the reverse order. If it is multiplication, then it's a power. Okay, it's an exponent. And again, you cannot distribute logs. Examples 1, 2, 3, 4, 5. We are doing the same set of instructions. It says write as a single logarithm with no coefficients. No coefficient means you can't have a leading number in the front. So number 1, log base 7 of 2 plus log base 7 of 8. The bases are the same and it is addition. So it becomes a multiplication. And no, you don't multiply the log either. So when you rewrite it as one single log, it becomes log base 7 of 16. Example number 2, log base 3 of 10 minus log base 3 of 5. It is currently a subtraction of log, and the bases are exactly the same. So it becomes a division. So when you divide, obviously in mathematics, you must always simplify. So log base 3 of 2 is a single log with no coefficient. Number 3, there is a coefficient in the front of 3. It does not want you to have a coefficient. So we're going to write log base 7. It's a product right now is 3 times log base 7 of 4. So that 3 becomes a power. So log base 7, 4 to the third, as you know already, that gives me 64. Can you see that when I'm writing logs, the subscript must be below? All of my subscript is below. Make sure you're mindful of where the subscripts go. If you write it on the same line like this, okay, that will be completely wrong. So make sure you're super careful of writing your logs. Number 4, you got 2 times log base 2 of x, so that will become an exponent here of power of 2, plus log base 2 of y to the 5th, because it's 5 times. Whenever you're reading 5 times log, so that coefficient in the front is going to be an exponent of some sort. Now the basis of log for both terms are 2. That means I can multiply these together. But when you multiply those together, I forgot the log base 5. When you multiply together, you can't do anything anyway, so you leave it without combining those. Last example for this set of instructions, you have 1/2 times log base 6 of a. So you know, this will become, the 1/2 will become an exponent. So log base 6 of a to the half minus log base 6 of b to the 4. Well, power of half, class, that's the same thing as a radical. So I'm going to rewrite it as a radical a minus log base 6 of b to the 4th. Okay, well, we still have a minus in the middle to take care of because it's wanting for us to write it as 1 log. So it's a subtraction. That means we are going to rewrite it as a division question. So that becomes final answer. Log base 6 over rad a divided by b to the 4th. Example 6 to 10. Expand the logarithm without any exponent. So now we're going to go backwards. Okay, so now they're giving us 1 log. Our job is to go as expand as much as possible. So now we have log base 5 of 3 times x. So when you say 3 times x, it tells me that we're going to be doing an addition. So now we have log base 5 of 3 plus log base 5 of x, and that is as far as we can go. Number 7, log base 4 of 7 divided by 9. Just like that, when you say divide, it is now a subtraction problem. So it's going to be log base 4 of 7 minus log base 4 of 9. Now I'm going to box this up and I'm going to go a little bit further because technically this can be rewritten as log base 4 here of 3 squared. It does not want us to have exponents, so that square needs to become a leading coefficient in the front. So that becomes 2 times log base 4 of 3. So you can take this first one, or you can have this one as an answer. Number 8, log base 4 of x to the 5th. Again, you cannot have an exponent. It said so in the instruction. So the exponent of 5 goes in the front. Then you write log base 4 of x, and that is as far as you can go. Number 9, you have a few different things here. You have log base 5 of 2 times x divided by y to the 3rd. So the first thing is you're going to go do log of 2 rad x and then minus log base 5 of y to the 3rd. Again, make sure you don't have any exponents. I need to go a little bit further here. Log base 5 of 2 plus log base 5 of square root of x. The power of 3 needs to be moved to the front of the word log to become 3 times log base 5 of x. Nope, you cannot keep it like this. You have to go further with the radical. This is now log base 5 of x to the half power minus 3 times log base 5 of x. And our last step is to move that half power to become a leading coefficient. So final answer is log base 5 of 2 plus 1/2 times log base 5 of x minus 3 log base 5 of x. And then box that up. It wants us to expand, okay? Oh, this one's, can you fix this last variable? These are all y's, my bad. Those are all y's, okay? Box it up. And last one in expanding, this is now log base 8 of x to the 3rd times, so that becomes an addition. So log base 8 of y. You can't have an exponent, so move that down as a leading coefficient. So 3 times log base 8 of x plus log base 8 of y, and that is as far as we can go on example number 10. Let's move over to the next set of instruction. Evaluate using the properties of log. So now your job is to give me an answer. So we have log base 6 of 12 plus log base 6 of 3. You can have a calculator, so our first step is to see its addition. So what you want to do is rewrite it as a multiplication. So that will give me log base 6. 12 times 3 is going to be 36. Well, you have a base of 6. This is what you have to be really careful about. Then you want to make 36 into a base of 6 as well when it's possible, with an exponent of 2. This will allow us to bring down the power of 2 and write it as 2 times log base 6 of 6. And remember, in the previous video, we talked about log base 6 of 6 being 1. Yes, that is 1. So this will give us 2 times 1, so our final answer is 2. And make sure you can do this without a calculator. Same thing with number 12. It's a subtraction problem. So the first thing we want to do is make it into a division question. 96 divided by 3, this is going to give us a log base 2 of 32. And again, look at your base. It's a log base 2. So what you want to do is, hey, can I break the 32 into a 2 to some power? And yes, you can. 2 to the 5th to be exact. So now the power of 5, rewrite it as a coefficient in the front. And again, this is the log base 2 of 2. That is also 1. So this will give us a 5 times 1, which will give us an answer of 5. Then on 13, we have a few different things here, so make sure we're very cautious of what we're doing. We have 1/2 times log base 5 of 15, take away log base 5 of radical 75. So the first thing we want to do is the 1/2. We want to write it, we want to write it as a power of 15. Well, log base 5 of radical 75. We want to, again, next step, well, 1/2 power is the same as square root of 15. From here, we're going to write it as 1 log, because the bases are the same, of rad 15 divided by rad 75, which rad 15 divided by rad 75, you can make it in one big radical, so we can simplify. This will allow us to write log base 5 of big radical, ready, 1 over 5. Now you can break it up. Yep, you can go forward and backward. So now this is log base 5 over square root of 1 is 1, square root of 5. Right now we're going to write it as square root of 5. Then you want to rationalize your radical. Multiply top and bottom by rad 5. Just like that. Then this will give us log base 5 of rad 5 on the top divided by 5 on the bottom. Well, it's a division problem. Of course, you can write it as a subtraction. So minus log base 5 of 5. Okay, well, log base 5 of rad 5 is really log base 5 of 5 to the 1/2. Well, don't we know that this is 1? Sure do. That is definitely 1, so that's minus 1. Move the 1/2 in the front. So log base 5 of 5 minus 1. Whoa, what? This is also 1. Yep, it is. 1/2 times 1 is 1/2. Take away 1. Your final answer is a negative 1/2. Bam! All of that work to come out a negative 1/2. No, this is not the only way that you can do this. There are multiple ways that you can do a math problem. And the good thing is, in math, you will always come up with the same answer. Okay, so we have another set here on example 14 and 15, and then the last one, oops, I'm sorry, I moved too much. The last one is changing base. Okay, so example 15, 14, and 15, they gave you log base a of x is 5, log base a of y equals 2. Use the properties of log to find the following. 14, log base a of x to the 3rd times y to the 5th. Because we said times, we will rewrite this as an addition problem. Well, we have powers, so we are going to rewrite it as a leading coefficient. So this is 5 times log base a of y. Now, if you think about this, is log base a of x, log base a of x. Well, it says in the problem log base a of x is 5. So this is really 3 times 5 plus. In the problem, it says log base a of y is 2. I do have log base a of y. So we are going to replace that with 2. Well, you got 3 times 5, that's 15. 15 plus 10, our final answer is going to be 25. And all of that has to be done without a calculator. Example 15, similarly, log base a of x squared divided by y to the third. Separate the division by writing it as a subtraction. Whenever you see a power, make it into a leading coefficient. So now 2 times log base a of x minus 3 times log base a of y. And we know log base a of x is 5. So that's 2 times 5 minus 3 times, we know log base a of y is going to be 2. So that's 10 minus 6. That will give us 4. Last set of instructions for this skill set. Now make sure you write this down right here. This is super important because if you have a scientific calculator, you actually don't have a base. You don't have a base of 4 or 5 or 6 or 7. Normally most scientific calculator has a base of 10. So when I give you a base that's not 10 and we have to use a calculator to get a decimal, then make sure we know how to do it. So I'm going to change a base. It says log base b of a. Log base b of a is identical to log base a divided by log base b. On 16, I'm giving you log base 4 of 22. If you have a calculator that it's only in base 10, then this is what we have to write. So highlight that because it says change a base. Now go ahead and take out your calculator and do me a favor and punch it in to see if you can give me a decimal approximation. Okay, now that you've gotten some time to work on your calculator skill, let's go find my calculator. This is just a basic scientific calculator. Some calculators will require you to type in 22 and then I hit the word log here. That's just the log of 22. Now I have to go divided by 4 and then I hit log. That's just log of 4. Then I have to go and hit enter to give me my final answer. So if you look at my screen up here on this top right corner where I'm circling right here, that's what it should show, which is about 2.23. So I'm going to go back and enter in about 2.23 for that answer. So 2.23. Box that up for approximation and box up your change of base. Now number 17, we will do the same thing. We will convert it to log of 152 divided by log over 5. Go ahead and take your calculator out. I want you to find the decimal approximation. Similarly to this one, log of 3 divided by log of 11. Notice how all the base, if you have the base, that's going to be in your denominator, okay? So now go and use your calculator and find the approximation for the next two. I will also take out my calculator here and clear out what I had before. I'm going to do 152 because that's just what my calculator says to do, divided by log of 5. So I do 5 first and hit the word log and then hit enter to get me an answer. That's about 3.12. Go back, write in about 3.12. Box that up. Same thing with the last example, 18. Log of 3 divided by log of 11. On my calculator, so you have to know what your calculator needs. So make sure you mess around to get this, a similar approximation as I have here. So clear out my old answer. I'm going to punch in 3 log. That's just log of 3. Now divided by 11 log, that's just log of 11, hit enter. It's going to be 0.46, and that's what we will write, 0.46, box it up, and guess what, guys? This is the end of this skill.